Welcome back to Small Lathe. We have an interesting project. This is a device that's used in my profession in biology, and you usually apply one of these and just run it. I don't know if you can hear that, but it's actually running when you push on this little tab and turn this, and this allows you to grind tissues, basically speaking, in a small Eppendorf tube, which I don't have at the moment. I'm not in the lab, I'm in a shop. So we have a small problem. As you can see, we can't connect it. There's usually a rubber connector that allows you to work in a flexible manner, because people don't have their hands synchronized and perfectly aligned. So we're going to try and make one. This is a hot melt glue rod stick piece of it, and I've never turned hot melt before. I have no idea. So I'm just gonna clamp it by hand, and we'll try and do something with that. And we don't have the parameters we need, though. We do know that the OD here, I can't take it apart. I tried. Not without brute force approach, which I will not do. So our OD here is, sorry, ID. So our ID here is 6 point something millimeters, 6.3. So 1/4 inch. And I'm going to turn this, which is about, I don't know, 8 millimeters ish, more or less. Yeah, around 7.7 millimeters to 6 millimeters. So it's going to be interesting because that's extremely flexible. We need to drill 4 millimeter, 3.5 millimeter. Let's put it 3.5 millimeter hole to match this in the center. And there's a rod there it should stick onto. It looks like 1.5 millimeters. So we're going to try that. I can't reach down there and measure it, so let's give it a shot. It's not going to look fancy, but I hope it's going to work. I have no idea. We'll have to wait and see. Right. Possibly a really stupid idea, but that's what we got. We don't have any other material that's flexible enough. On one hand, I could make one from brass and make an O-ring to hold this. That's plan B. But let's skip plan B and start with plan A, and let's try and see what we can do. We just faced some hot melt. It still has some burrs, but hey, that's worth it. Okay, here we go. We need to adjust the angle. Yes, like that. That looks rather ugly. I'll give it a second shot, and if it doesn't help, we'll try and switch to something else. Okay. It's of course it's flexing. It's hot melt. Let's try and put a centerpiece there and see what we can do. Oh, drills rather nicely, if I say so myself. So let's take a 2.5. You know what? Let's take a 1.5 millimeter drill bit. Okay, I thought we'd have a friction issue. This is glue and a fairly sort of sticky material. So it's melting its way, not drilling its way, but we can fix that, I guess. A little bit of oil and we can do something about that, I think. Just like turning acrylic. Okay, let's see what we can do there. Okay. Hey, not bad at all. It's always nice to be talking to yourself, especially when you think the camera is on and it's not. So, sorry about that. Already drilled through. I can't tell if I told you guys or not. This is our live center. Let's see how it goes. First try was really ugly because the material is flexing. This will give it some sort of a controlled approach. Much better. Surface finish is not brilliant, but it is much better. Okay, I'm going to be needing something to cool this off because it's heating up to blob. Okay, cutting under oil. Now that's a smooth surface. I can feel some ridges, so the material has flexed, and we should. And so we need to go back and forth without changing the diameter and just doing it again. Let's try. That looks pretty good. Okay, we got some, I wouldn't call it chips, maybe I'd call it some rings of material there we could get rid of. I'll try and get rid of that after I get it out of the chuck jaws. I think we're more or less ish on the mark. Let's try and see that. That is 6. Aha, 6.0. Okay. Oopsie. Let's clean that up. Looks good. Where's that thing? There we go. Fits nicely. Okay. Let's release it and look at that thing. Not bad at all. Okay, now we see the problem. This is a 1mm pinhole thingy. So basically I have to do everything from scratch. Alright, this should give us an optimal diameter of 6mm, and let's get those shavings, if you could call that shavings, or chips, off, and we should be around the 6mm. Let me check. .0mm. Well, there's an easy check for that. Let's see if it fits. Oh yeah, fits marvelously. Will it stick in? Oh yeah, it will. I think we got a working setup. Let's put it in there. Now it's in nice and tight. It's not going in anymore. Looks good to me. Wow, that really grabbed that motor. Now it's running. Okay, so we got a shaft, and now we need to hold our pestle. And gently drill it. Not all the way, about, I'll leave a millimeter from the top. Let's see. Oh, it's a nice fit. It's a fairly snug fit. Let's call it a prototype drill. Stick that in there. Okay, much better once I got it centered. Now remember, this is supposed to grind inside a tube. I'll just mark this like that so you can see. I don't want to completely paint it halfway through, but it works really nice. Well, we got a prototype. Let's pluck one out, pluck one in. So there we go, prototype 1. And this is going to give us a good grip, and we can run this little thing and grind through. Well, that's it. Thanks for watching. Hope you enjoyed. Have a sweet day.